spray chamber. Introduction. Objective.
As we all know, that spray chamber is one of the best equipment that being used in most of industry. But we have to know what is the objective of this equipment. There's three that we have discovered. The first one is to capture or remove the pollutants when using the liquid, as the liquid is water. And next, remove the particles such as gaseous components, sticky particles, and also hygroscopic. Lastly is removal efficiency varies between 70% to 99%, depends on the particle size. Besides, we also have to know what type of industry use this type of equipment. As we know, spray chamber mostly used to separate large particle and highly soluble gases. It is not only to use to clean the air gas, but it also being used to in the drying process, such as making the dry powder, or can be used as fertilizing process for making the fertilizer. But for cleaning the gas for industry, you can use it in the plastic industry, glass industry, pharmaceutical industry, and also chemical industry to separate the dust or aerosol.
Major parts.
There are some major parts built on the spray chamber in order to ensure the continuity and efficiency of the process. For the first major part, which is the body chamber, this is where the impaction between the gas and liquid occur in order to trap the particulate matter. And then for the second major part, which is the nozzle, in this part, this is where the water droplet will be dispersed, and the size will be specific depending on the sectional area of the nozzle. Then for the third major part, which is the inlet part, this is where the gas or the dirty gas will be fed into the body chamber. For the next major part, which is the outlet part, this is where the clean gas without particulate matter will be discharged. Then for the last part is the effluent hold tank, where this tank will collect all the slurry from the impaction between gas and the liquid. That's all.
Basic principle.
Hi, so this is the basic principle of spray chamber. Okay, first, water is sprayed or dispersed in fine droplets through sprayer or nozzle at the top of the chamber. Second, the droplet size is controlled to optimize particle contact and droplet separation from the gas stream, where the gas stream is fed tangentially from underneath, so informing on the current flow. Spray chamber can also be oriented cross flow and concurrent flow. Polluted gas contacted with the scrubbing liquid, and next water sprays downward from the nozzles mounted on the walls of the tower or mounted on an area of the center of chamber. Next, the droplets capture particles suspended in the gas flow through initial impaction, interception, and Brownian diffusion. Droplets large enough to settle by gravity collect at the bottom at the chamber. And next, droplets that remain entrained in the gas stream are collected on a mist eliminator upstream at the nozzle. Next, the required contacting power is obtained from an appropriate combination of liquid pressure and flow rate. To calculate the efficiency, the following equation is used.
There are three mechanisms which are effective in particle removal for the spray towers, which is 1. Initial impaction, 2. Interception, and 3rd is Brownian diffusion. Initial impaction. A particle is so large that it is unable to quickly adjust to the abrupt changes in streamline direction near a filter fiber. The particle, due to its inertia, will continue along its original path and hit the filter fiber. Predominant when high gas velocities and dense fiber packing of the filter media is present. Direct interception. Interception occurs when a particle, which is following a gas streamline, comes within one particle radius of a filter fiber. The particle touches the fiber and is captured, thus being removed from the gas flow. Brownian movement. Diffusion. Gas moves in a random zigzagging path known as Brownian motion. As the gas molecules collide with the dust particles, which is below than 0.1 micrometer, they also start to move in similar way. The smaller a particle is and the slower the flow, the more time it will have to zigzag around, hitting and sticking to a filter fiber.
Advantages. Disadvantages.
Hi, today I will explain about the advantage and disadvantage of the spray chamber. Okay, spray chamber has a simple implementation. Next is have a relatively low pressure for the operation. Can handle flammable and explosive dust with a little risk. It relatively has a low capital cost, free from plugging, and small space requirement for the equipment. Lastly, the spray chamber is effectively can remove large particles and highly soluble gases. Okay, for disadvantage of the spray chamber, it may create water or liquid disposal problems. For waste product collected from the spray chamber are wet. Next, disadvantage of the spray chamber is relatively inefficient in the removing of the fine particulate matter. Spray chamber also have a relatively high operating cost. Next, the spray nozzle plugging or eroding, especially when using the recycled scrubber liquid. Spray chamber mass transfer is not very efficient for the operation.
Operation. factor efficiency.
The most important thing that will affect the efficiency is the design itself. The design has so many requirements. Some of them are temperature and also physical absorption for the particles. However, in order to design this equipment, the stream properties play the most important role. These are some aspects that have to be considered, such as the state of inlet, density of particles, and also the viscosity of the particles. With these elements, we can know the suitable inlet nozzle size that can be used. Besides, the size of particle is one of the major issues that will affect the efficiency, but it also depends on the droplet size, where the smaller of droplet size, the higher the efficiency. This is because smaller size will trap more unwanted particles, since there is more drops that can be released per time. Even so, the droplet's velocity must be suitable with the droplet size. Theoretically, it can be said that higher velocity will give higher efficiency. In spite, these factors will affect the collection efficiency if they not being considered properly.
Recommendation. There are some recommendations in order to increase the efficiency of spray chamber, such as nozzle size, blower control, droplet size, and the cleaning of equipment. For the first recommendation, which is the nozzle size, build smaller cross-sectional area of nozzle in order to increase the velocity of water droplet. Increasing the relative velocity between the gas and liquid droplets will increase the particulate momentum and allowing the smaller particles to be collected during the impaction. For the second recommendation, which is the blower control, use suitable blower for the equipment in order to increase the gas velocity and create better impaction during the process. For the third recommendation, which is the droplet size, it is recommended to use nozzle that can produce smaller droplet size. This is because smaller droplets will have larger surface area to volume ratio and can capture more particles per volume of liquid injected. However, if the droplet size becomes too small, it will decrease the relative velocity between the droplet and particles. Hence, it is very important to use nozzle that can release suitable droplet size to achieve high efficiency. For the last recommendation, which is the cleaning of equipment, ensure the equipment is cleaned before operating. This is very important to avoid any residue left in the equipment which might affect the efficiency. If the equipment is cleaned before operating, it will have better efficiency and better performance.